Hello everyone, my name is Karthike and today we'll be talking about a very important topic of physics, that is electricity. You must have seen many electrical appliances in your houses. For example, TV, fridge, electric oven, iron. How do they operate? Yes, you are right. They operate due to the electricity only. For example, if there is no electricity in the house, then how would you watch TV? How would you use your electric iron? Right? That is not possible. So that electricity is very important, and that topic only will be talking about electricity. So let's see what is electricity. Electricity is nothing but it is a type of energy only, right? It is a type of energy that is resulting due to the flow of charges. This electricity, this form of energy is caused due to the flow of charges. The charges flow and they create electricity. Now first of all, the question comes in our mind, sir, what is this charge? What is this electric charge? Now this electric charge is a fundamental quantity, and this is a fundamental property of a matter, or we can say or of an object, that is caused due to the lose and gain of electrons. So this is very important, that if the electrons are gained by an matter, by an atom, if any atom gains electrons, then negative charges are prominent on that atom. And if an electron loses if an atom loses electrons, then what happens? The positive charges is dominant on that atom, right? So this is a fundamental quantity. Electric charges are what? They are fundamental quantity, just like mass, just like weight, just like electric current is also a fundamental quantity. So what is fundamental property? That electric charges are fundamental property. Now the thing comes that what are electric charge and how you can denote an electric charge. Electric charges are denoted by Q, capital Q. Capital Q is used to represent the electric charges, and the SI unit, very important beta. This SI unit comes in your exams, that what is the SI unit of, means how can you measure the electric charge on any matter, on any atom. So you have to measure the electric charges in Coulomb. Coulomb is the name of a scientist. So on the honor of this scientist, this SI unit of charges is given, that is Coulomb. Now there are few properties of electric charges. Okay, so first and very important property of electric charges is quantization of charge. Now what is the meaning of this quantization of charge? You must have seen that we can count numbers, right? Same and similarly we can count the charges, and these charges are never present in any decimal form. For example, if I say that any atom or any object has 1.5 charge, have you heard about this? No. Suppose any atom, any matter has 0.2 charge, 0.2 Coulomb, for example, if you want to measure. No, this cannot happen. So this quantization of charge tells us that charge on any object or any matter is always present in their integral multiple, means charge is always present in a whole number only. Okay, for example, if I can say that any object is having 1 Coulomb of charge, any object is having 2 Coulomb of charge. This cannot happen that any object is having 2.5 Coulomb of charge. No, this can never happen. Okay, so this is called quantization of charge, and I told you that electric charge is represented by capital Q, and the formula of quantization of charge is NE. Now what is this N? N means any integer number, any integral number. This is N. So here the value of N can be 1, 2, 3, 4 or up to infinity. And what is this E over here? This E is nothing but charge on one electron, and this value also you have to remember, that is 1.6 into 10 to the power minus 19 Coulomb. This is the charge on one electron, and this is the smallest possible charge on earth. Okay, so this is the value. There is a fixed value of electron. Charge on one electron is nothing but 1.6 into 10 power minus 19 Coulomb, and electron, you know this, that has a negative charge, so this is a minus 1.6. and suppose if anybody asks you what is the value of, means what is the charge on one proton, so proton, you know this, that it is positive particle, so it is plus 1.6 in 10 to the power minus 19 coulomb. This is charge on one proton. Okay, so now the another physical quantity that comes in this chapter is electric current. Now what is electric current? Electric current is produced due to the flow of charges, and we can define electric current as rate of flow of charges. You know this, that if anything, for any physical quantity this word rate comes, rate means for a particular period of time, right? So the rate of flow of charges per unit area through a conductor is called electric current. So obviously we know this, that electric current is flown in a conductor only. A conductor conducts electricity. So in a conductor, rate of flow of charges per unit area. Okay, so this is called electric current, and you have to remember this, that electric current is always represented by capital I. Capital I is equals to this, what is Q? We have talked about that it is electric charge. So I is equals to Q upon T. Q means charges, electric charge, and T is for time. Rate of flow of charges, rate of flow of charges means time, right? In a particular time period, how many charges flow through a conductor produces the current. Now from here, a very important definition comes in your examination, that is define 1 ampere. That how would you define that, how would you say that, sir, this is 1 ampere, this is the amount of current produced called 1 ampere. So this definition, you have to remember this. You can easily remember from the formula itself. You can see that 1 ampere is equals to 1 coulomb upon 1 second. So easily you can define 1 ampere, that if 1 coulomb of charge flows through a conductor for 1 second, obviously, right? So if 1 coulomb of charge flows through a conductor for 1 second, then the amount of current produced in the conductor is equals to 1 ampere, obviously. So if 1 coulomb of charge flows through the cross section area of a conductor for 1 second, then the amount of current produced is equals to 1 ampere, obviously, right? So this is the definition of 1 ampere, very important. Okay, so now let's talk about another physical quantity, and this physical quantity is very important for the flow of charges. Now you tell me, why do the charges flow? Yes, you are guessing right. It is due to the potential difference only. Now if there is some difference, then only any flow can happen. You know this, that the air flows from high pressure to low pressure, right? Suppose if the pressure difference is same, can the air flow? Obviously not. Same goes with the charges also. If there is difference, then only the charges will flow. If there are some if there is large amount of charge, and if suppose there is a less amount of charge, then only the transfer of charges will happen, then only the flow of charges will happen, and this is called potential difference. This is the reason why you can see the positive terminal and the negative terminal of a battery, right? So what is the significance of that? That is to create the potential difference. What is the significance of a battery? What is the significance of a cell? To create the potential difference. If the potential difference is created, then only the flow of the charges happens, then only the flow of charges takes place. Let's have a look, what is electric potential, what is potential difference. So electric potential means the work done, right? The work done, the energy. The work is nothing but energy. The work done to carry a unit positive charge from infinity to a particular point is called electric potential. So unit positive charge means, suppose if I take any charge whose value is 1, unit means 1. So if I take any positive charge is represented by Q. To bring this charge from infinity, in physics we say a large distance, we say it as infinity. So infinity means nothing but from very large distances. Okay. So from very large distances, if I take this charge Q to a particular point, that work done is called electric potential. And from here only we can say that what is potential difference? Difference means from 2 points. So if the work done to carry a unit positive charge from one point to another point, suppose this is point A and this is point B. If I take this positive charge from point A to B, the work done to carry this unit positive charge from point A to point B, the energy that I have to give to this charge so that it can move from point A to point B, this can happen from here to here also. So this work done is called potential difference, and the potential difference is very important. It is represented by V